Good afternoon, everyone. Welcome. My name is Nikos Damatis. I'm Secretary General of the Hellenic Biomass Association, and I would like to welcome you in this webinar and national roundtable discussion about renewable heating and cooling in Greek municipalities, which is organized jointly by the Hellenic Biomass Association and the Center for Research and Technology, Hellas, on behalf of the European Technology and Innovation Platform on Renewable Heating and Cooling, and under the support of Bioenergy Europe. This event aims at exploring the progress made by a representative number of Greek municipalities in the field of renewable heating and cooling across a wide range of technological spectrum, and to highlight the path yet to be covered in order to achieve the energy and climate objectives of the renewable heat and heating sector for the benefit of local communities, regional development, and the environment. Francisco, if we can have the slides, please, for the agenda. So today's today's event consists of two parts. The first part, we have two speeches, the keynote speech by Mr. Ioannis Maniatis, who is former Minister of Environment and Energy and Climate Change and Associate Professor at the University of Piraeus, and a speech on the heating and cooling for sustainable cities from Mr. Ioannis Georgizas, General Manager of Sustainable City Network of Cities. And the second part, it's a roundtable discussion, will be moderated by my colleague Manolis Karampinis, Research Associate at the Center of Research and Technology, Hellas, and Board of Member for HellaBiom and board member of the European Bioenergy Association, Bioenergy Europe. And we have four participants there. Manolis will refer to our panelists later on. Next slide, please. The organizers, first of all, the European Technology and Innovation Platform on Renewable Heating and Cooling brings together stakeholders from a whole spectrum of technology, from biomass, geothermal, solar thermal, heat pump, district heating and cooling, and thermal storage, in order to define a common strategy for increasing the use of renewable energy technologies in the heating and cooling sector. Bioenergy Europe is the voice of the European bioenergy. It was founded in 1990. It's a non-profit organization based in Brussels, and it aims to develop sustainable bioenergy market based on fair business conditions, and brings together associations from 42 countries and 135 individual companies, as well as members of the academia and research institutes across the whole of Europe. The Hellenic Biomass Association is a non-profit organization of corporate members and individual scientists, and one of the principal national associations in Greece in the sector of renewable energy sources since the 1990s. And it promotes sustainable biomass valorization within a modern circular bioeconomy context to the benefit of local communities, the environment, and economy. I will give the floor now to my colleague Manolis, who will present CERTH and the European projects AgroBioHeat and BICU, which support this event. Manolis, the floor is yours.
Good afternoon also from my side, and welcome everybody. CERTH is one of the organizers, the Greek organizers of this event. We are a research organization, the largest, I think, in Greece, and one of the largest on the EU level as well. We are supervised by the General Secretariat for Research and Innovation of the Greek Ministry of Development and Investments. We are organized into 5 different institutes dealing into different research priorities. I myself am coming from the Chemical Process and Energy Resources Institute, and Sustainable Energy, which is the main focus of today's discussion, is our core competence, one of our core competencies. We're essentially a self-supported research center. Most of our annual turnover, which is about 40 million euro, is coming from competitive research projects. And as a matter of fact, we are among the leading positions in the European Union among research centers when it comes to attracting funding from the Horizon 2020 program, and the first among all types of organizations in Greece. We employ more or less more than 1,000 people, and we are based in 6 regions and 7 cities in Greece, our headquarters being in Thessaloniki, but we also have strong presence in Athens, for example, where I'm located, Ptolemaida, Rhodos, and elsewhere. Next slide. So this event is kind of co-sponsored and supported by two projects in which CERTH is involved, and they are actually quite relevant for today's discussion. The first, AgroBioHeat, aims to support the development of renewable and, especially considering today's situation, cost-effective heating projects using an abundant but totally underutilized energy resource in Europe, biomass that is coming from agriculture, things like straw, prunings, and others. Within the project, we promote modern technological solutions capable of achieving high efficiencies as well as low emissions. It is coordinated by CERTH, and actions are implemented in 6 different countries, including Greece. On the other hand, the Big Coup project is also strongly connected. It aims to develop and support renewable energy communities that are primarily focusing on exploitation of local and sustainable biomass resources. Here, actions are mostly implemented in 4 pilot regions. In Greece, we have a pilot project in the Karditsa, in the energy community of Karditsa, and this is implemented by a SEC. You will hear more about this from Vasilis Philippou later on, and supported by CERTH. So that's all from my side for now, and I will now give the floor again to Nikos to introduce our first speaker.
Thank you, Manolis. And I would like to call to the floor Mr. Ioannis Maniatis, who is a former Minister of Environment, Energy and Climate Change and Associate Professor at the University of Piraeus. He will deliver the keynote speech for today. Mr. Maniatis, the floor is yours.
Nico, thank you very much for the invitation to participate in this very interesting meeting. I hope that our presentations and as well as our discussion will be useful, especially in these times with the energy crisis and all these issues we are seeing on our televisions, etc. Let me just start with few remarks I have already prepared. In line with the ambitious goal of climate neutrality as expressed through the European Green Deal, the EU and Greek economies need to follow a path of drastic decarbonization in all sectors of energy production, from electricity generation up to heating, cooling, and transportation, while at the same time remaining as autonomous and energy secure as possible. Heating and cooling represents almost half of the EU's final energy consumption, and carbon sequestration has been identified as a priority at European level. Fit for 55 strategy, an important intermediate step towards climate neutrality, aims to achieve a reduction of greenhouse gas emissions by 55% by 2030 compared to 1990 levels. It is therefore an opportunity to have measures to upgrade obsolete heating plants and installations with modern renewables such as biothermal, geothermal, solar thermal, district heating, and heat pumps. These modern and sustainable solutions increase energy efficiency, reduce emissions, and of course tackle air pollution. In most European countries, EU countries, at least 25% of heating installations are over 30 years old. In fact, in some of these countries, the percentage of age exceeds 33%, which means that 1 in 3 facilities do not currently conform to modern requirements and specifications. Therefore, a faster rate of replacement is needed to meet both the 2050 final target as well as the intermediate end of the decade targets of climate neutrality. According to recent statistics, and I'm referring to 2019, the heat and cooling sector continues to be largely dominated, about 78%, by fossil fuels, with 136 million tons of oil equivalent coming from non-renewable sources, mainly fossil gas. In the same year, 2019, heat from biomass contributed 17% of total energy sources and represented 85% of the total consumption of renewable heating and cooling, eliminating the emission of 160 million tons of CO2 equivalent. This amount of emission savings corresponds, for example, to the combined annual greenhouse gas emissions of Belgium and Slovakia, which shows the dynamics of the contribution of biothermal energy to the objectives of the European Green Deal. Another important and yet to be developed renewable energy source for heating and cooling is, as we all know, solar heat. For this issue, I start with 5 short remarks. 1. It is a European-driven renewable technology that with a cost of about 1,000 euros saves the same amount of CO2 with the CO2 saving of an electric car that costs about 30,000 euros. Second remark, it is a mature renewable technology that produces the same amount of megawatt hours per annum, per year, as a photovoltaic system, but with half of taken area. Third point, it is a renewable technology that mostly promotes energy democracy. It is fully decentralized, tackles energy poverty, is compared in cost with natural gas, with the old one, prices of natural gas. It is by 90% based on European technology and materials and can save about 100 or even 200 billion euros from fossil fuel inputs. Fourth point, it is a mature renewable technology with the less political and funding interest, with no European strategy or legislative package, with no interest by the commercial banks, as well as the European funding mechanisms. And my fifth comment is that this technology is a renewable energy Greek industry that employs more than 3,500 employees in 22 small and medium enterprises, and this production, these small and medium enterprises export more than 60% of their production to the United States of America, to China, to Japan, to the Gulf countries, etc. I dare say that this is the elephant in the European energy room. The energy elephant of few discussion and interest in institutions when deciding the European Green Deal and decarbonization of the European economies till 2050. So much discussion, directives, funding, interest, governmental decisions about electricity, and on the contrary, very few publicity, interest, legislation, and funding about the triple magnitude of heating and cooling. The climate crisis already costs Europeans dearly. In 2017, the cost of extreme weather-related damages cost 283 billion euros, according to the European Environment Agency. That same year, the European Union spent 266 billion euros in order to import fossil fuels from third countries, the majority from Russia. In Europe, with circa 11 million of solar thermal systems in operation, we have 7 million tons of annual CO2 emissions savings, about 2 billion euros of sector turnover, and more than 20,000 jobs. Worldwide, solar heat employs some 730,000 workers and generates a turnover of 21 billion euros. This sector, the sector we're discussing about, is mostly decentralized, including over 120 million individual boilers, mostly old and inefficient, that need replacement. Let me now say that I am proud that during my incumbency as Minister of Environment, Energy and Climate Change 11 years ago, back in 2011, my country included heating and cooling in the form of thermosiphon at the very successful project of energy savings at home. In Greek, we call it exokonomokateko. The project had a total budget of about 500 million euros, invested on 40,000 houses with a yearly total energy saving of about 1,700 euros for each household. Let me repeat the number, 1,700 euros each year for each one household saving. This project and its strategy has been ranked as the second better European just after the Spanish one. We have achieved this with the help of the 22 Greek small and medium enterprises that produce thermosiphons of excellent quality, employ more than 3,500 employees, and some of them are between the 10 bigger all over the world, bigger in export to third countries. This project, during the 10 years of its application, included a total investment of about 98 million euros. From the top European markets, those showing the largest growth during the last 2 years were Denmark, with an increase of about 174%, and the Netherlands, with an increase of about 44%. Among Southern European countries, the main market, which is Greece, has grown by only 10%. The largest European market remains the German one. Solar thermal, providing energy at the lowest cost among all other renewables, can also help in reducing energy poverty. European companies are leading in terms of innovation, and especially in large systems such as district heating or solar heat for industrial processes. Furthermore, this sector is an exporting sector, with annual net exports surpassing at times 1 billion euros. The Renewable Heating and Cooling Alliance that has been formed 1 or 2 years ago calls for a robust policy and funding framework to ensure that 50% of the total heat and cooling consumption by 2030 comes from solar heating, heat pumps, geothermal energy, biomass, and renewable district heating systems. This vision should deliver 300,000 new skilled jobs, reduce emissions by more than 750 million tons of CO2 equivalent, develop local industrial supply chains, and importantly, low-cost, high-value heating and cooling solutions for customers, as well as reducing dependency on imported fossil fuels. Now, concluding, let me say that it's time to act now, especially after the skyrocketing of natural gas prices during the last months of energy crisis and, of course, the Russian invasion in Ukraine. Europe has a moral and economic duty to take action on the following 5 issues. 1, a renewable heating and cooling package. Second, a renewable heating and cooling strategy to be included in all national energy and climate plans. Third point, EU funds and financial instruments to deploy and further develop renewable energy sources, heating and cooling technologies. Fourth, planned replacement of old inefficient heating and cooling systems. And fifth point, highly skilled workforce for renewable heating installations. Dear friends, these were my remarks. I hope these were useful and will be useful maybe for the discussion that will follow. Thank you very much once more for the invitation to participate in this very, very interesting meeting.
Thank you very much, Mr. Maniatis. It's an honor having you with us. You have a long experience in these matters, and we hope that, as you correctly mentioned, biomass heat and solar heat can play an increasingly important role in the next years, as we have all this crisis in place. So thank you very much, and we will communicate soon again. Thank you.
Thanks.
So our next speaker for today will be Mr. Ioannis Georgizas, who is a general manager of the Sustainable City Network of Cities. And he will talk about this important network, which strengthens the bonds among Greek municipalities. And he will give also very precious examples on the renewable heating and cooling sector. Before passing him the speech, I just forgot to tell about the question and answer session. Obviously, for those who are not familiar, you can use the Q&A, and all the questions will be answered after the roundtable discussion. So, Mr. Georgizas, the floor is yours. Thank you very much for participating in this event.
Thank you very much. Good evening to all. Thank you for the invitation. I'm Yannis Georgizas, the General Manager of Sustainable City, which is a non-profit organization that has established since 2017 by a group of mayors. First of all, Dimitris Kafadaris, who was the mayor of Pylos Nestor, now is the president of Sustainable City, and is also the general secretary of Central Union of Municipality in Greece. Next slide. Thank you. Which is our purpose, is to support municipalities in order to be funded from European programs like Horizon 2020, LIFE, and others, and as well as to support our members to finish technical studies depending on technical projects. Next, which was the problem? The problem in the municipalities, especially for the small municipalities that are not be able to be funded by European programs. This is a general problem in Greece, and this is the problem that we try to solve. Next, yeah, thank you. Now we have 72 municipalities in Greece and Cyprus. We have one municipality in Cyprus, municipality of Aradipou, near Larnaca. We have a National Technical University of Athens as member, as well as Maniatakio Foundation, the Institute of Environment and Sustainable Development of Cyprus, and the Regional Association of Solid Waste Management Bodies of Peloponnese region. Next. So, since 2017, we have already submitted more than 50 European proposals. We have ongoing 8 European projects. We have finished more than 50 programmatic agreements with municipalities, depending on technical studies that refers to technical projects. We have a major project. We have finished the design of a group of 15 waste transfer stations in Peloponnese, in region of Peloponnese, and we focus on virtual net metering and energy communities. Next, allow me to tell you about some projects. First of all, the Waste Up. It is the first project that our first project. Its objective is to research on the utilization of municipal bio-waste and the conversion into innovative high-value products like bioplastics, bioethanol, biocarbon. The pilots are established in Athens, Chania, Valencia, London, Alicante, Prague, Alcudia, and Tarni. Which is the role of sustainability is to disseminate and raise awareness of citizens through our municipality members, and we have selected two municipalities, Varivoula, Vouliagmeni, and Hellenic Argyropolis, to be part of this project. Next, please. Another project is Living Street, which is a very attractive project. We support 2 municipalities by funding of 2,000 euros in order to close a street partially or completely, permanently, in order to give the opportunity to citizens to be part of community actions without cars and vehicles. The CEDO is another project. The CEDO is a project with which we share data, tools, and cloud services to develop target and effective policies for managing emergencies like floods, fires, power outages. We work together with National Technical University, with the professor, Mr. Raspounis. In Greece, a platform that can be used by municipality to deal with emergency power outages is going to be developed. The municipality where we plan to establish the pilot project is the municipality of Kalki. Next, please. Another very attractive project is PowerPool. We work together with the National Technical University, Professor Mr. Doukas. With this project, we try to support energy poor citizens to implement practices to improve energy behavior and participate in joint energy initiative. We support municipalities in order to establish energy poverty offices, and with executives called mentors, will calculate the energy poverty in a municipality, which is a very crucial thing in order to be prepared for the next step to support these people, these persons, these families. Another project is PathLC, with which we create networks with stakeholders from public authorities to enable mutual learning. The participating municipality will benefit from exchange of knowledge through the interaction of municipal stakeholders around Europe and with capacity building through various tools, expert input, and a mutual exchange of experiences. Next. EcoSense. EcoSense is another attractive project. The project aims to support municipal enterprise for effective implementation of the actions to reduce their carbon footprint and get adapted to climate change. It focuses on the design of the integrated EcoSense platform and label, which includes 4 main software and hardware tools to support decision on carbon footprint mitigation action and actions for the adaptation to climate change of public sectors enterprises. These tools will be developed based on existing tools of participant partners like the data grid, tailored according to the new needs and appropriate interconnection of the EcoSense platform. Finally, allow me to discuss about the case study that is relative to this conference. We have finished a complete design for an installation of a solar thermal system at the first primary school of Messini. Next. To support the main heating system of the school, a solar thermal system is installed to utilize solar energy heating both for the building and for the building supply of hot weather. 2 inertia tanks of 1,000 and 2,000 liters capacity, respectively, are installed in the boiler room and are heated by the solar panels through a heat exchanger inside them. A heat exchanger is a device used to transfer heat energy between 2 fluids with different temperatures. Within the 1,000-liter inertia tank, there is an additional tank in a tank for the building hot water supply, which is also heated by solar energy, resulting in significant energy saving. The whole installation is controlled by a controller, which adjusts the boiler water temperature according to the environment temperature. The controller gives priority to heating from the sun, and if it's not sufficient, the boiler is switched on for additional heating of the water in the tanks. Next, please. For the ventilation of the building, a heat recovery exchanger will be started in combination with the network of air ducts and vents that achieves great energy savings between the hot air that exceeds the building and the cold air that enters it. The exchanger will be able to accommodate medium and high efficiency filtration with filters within the unit. The ventilation unit can be mounted horizontally or vertically. It will work in conjunction with the CO2 sensor, and when CO2 levels exceed the permissible limit, it will supply fresh air to the room. Next. In the building, ventilation is switched off. If the building ventilation is switched off and the internal temperature rises above the desired temperature, the exchanger will control the outdoor air temperature, and if it is lower, it will allow the outdoor air to flow into the building, thus reducing the indoor temperature, especially during the night, in order to reduce the energy required for air conditioning when the building comes back into operation. The ventilation unit can select different speeds for the supply and the return fans. And also the exchange offers the possibility of 24-hour ventilation operation by implementing ventilation operation at regular intervals through scheduling. The whole project costs not only the cooling and heating system, but the whole energy upgrade and renovation of the building costs of 500,000 and 25 euros. Thank you very much.
Thank you very much, Mr. Georgios. It's really very important, the work that you are doing at the Sustainable City Network. It's about bringing knowledge to the municipalities, joining forces and seeing what are the various opportunities of the renewables in different applications. And for sure, renewable heating and cooling has a lot of applications in the future. So thank you very much for your effort, and we wish you good luck for the next projects that you are undertaking.
Thank you too. Thank you too. I hope we will have the next project together.
Yes, of course, of course. We're looking forward to that. So I will now pass the floor to Mr. Manolis Karampinis, who will be moderator for the second part, the roundtable discussion about renewable heating and cooling in Greek municipalities. Manolis, the floor is yours, and you can make the presentation of our dear panelists.
Thank you, Nikos. I think for this next section, we managed to find 4 very different and quite diverse cases of how renewable heating, for the most part, is used by Greek municipalities, or could increase even further, which represent a quite diverse set of regions, climate conditions, as well as energy sources. And I think most of these projects or initiatives that we will present have a quite innovative character as well for the Greek conditions, at least. I think the speakers are conveniently arranged in alphabetical order, in the Greek alphabet, but also in a way that ladies, or the only lady we have in our panel, comes first. So I would like to give the floor to Miss Eleni Intzepelidou. She's the Deputy Mayor of Administrative, Financial Services, Energy and Agriculture, Natural Resources of Traianoupolis Municipality entity within the Municipality of Alexandroupolis. Ms. Intzepelidou, if you can turn on your camera and your microphone. Perfect. Ms. Intzepelidou will give the presentation in Greek. The slides that will be shared are going to be in English. So if there is a need, I think I'll speak Greek for a moment. Κύριε Τζεπελίδου, φαντάζομαι ότι ακολουθείτε λίγο πολύ και θα πείτε ότι παρουσιάζετε τις διαφάνειες.
Είναι μόνο να καλησπερίσω θέλω να σας ευχαριστήσω για την πρόσκληση. Χαίρομαι ιδιαίτερα που είμαι ανάμεσά σας προκειμένου να διερευνήσουμε τις δυνατότητες αξιοποίησης των ανανεώσιμων πηγών ενέργειας της χώρας μας για ψήξη και θέρμανση, που είναι το βασικό μας θέμα, και ταυτόχρονα συμβάλλοντας στη μείωση του ανθρακικού μας αποτυπώματος. Εγώ θα ξεκινήσω τώρα με την πρώτη. Εγώ βλέπω στα ελληνικά, έτσι.
Ναι. Το κοινό βλέπει στα αγγλικά και αν χρειαστεί, απλά αυτό ήθελα να πω. Αν είναι κάτι που υπερβαίνει το κείμενο διαφανειών, θα προσθέσω, θα το μεταφράσω στα αγγλικά.
Okay, thank you. Εφαρμογή γεωθερμικής, αστικής και αγροτικής τηλεθέρμανσης στην Άφια και Αρίστινο Τραϊανούπολης του Δήμου Αλεξανδρούπολης. Θα ξεκινήσω με τις γεωτρητικές εργασίες στο γεωθερμικό πεδίο Αριστίνου, όπου οι έρευνες ξεκίνησαν στα τέλη της δεκαετίας του 80 και συνεχίζονται έως και σήμερα.
Next slide, please, Francisco.
Όλα εντάξει?
Ναι.
Έως και σήμερα έχουν κατασκευαστεί 20 γεωτρήσεις σε βάθη από 120 έως 500 μέτρα. Η πλέον ενδιαφέρουσα γεωθερμική ζώνη καλύπτει μια περιοχή σχεδόν 12 χιλιόμετρα με θερμοκρασίες από 50 έως 99 βαθμούς Κελσίου. Το διαθέσιμο θερμικό φορτίο για άμεσες χρήσεις υπερβαίνει τα 50 ΜΒ. Next, please. Η κατασκευή της νέας παραγωγικής γεώτρησης ΑΑ6P σε βάθος 410 μέτρων και οι δοκιμές παραγωγής ανέδειξαν το σημαντικό ενεργειακό δυναμικό των γεωθερμικών ρευστών. Η θερμοκρασία των ρευστών μετρήθηκε στους 99 βαθμούς Κελσίου το 2019, η οποία είναι η μέγιστη θερμοκρασία που μετρήθηκε ποτέ μεταξύ όλων των γνωστών γεωθερμικών πεδίων χαμηλής ενθαλπίας σε όλη την Ελλάδα. Η πρώτη φάση του έργου αστικής και αγροτικής τηλεθέρμανσης περιλαμβάνει την χρήση των παραγωγικών γεωτρήσεων ΑΑ3 και ΑΑ6 με μέγιστη αξιοποιήσιμη παροχή 150 κυβικά την ώρα και ελάχιστη λειτουργική θερμοκρασία 90 βαθμούς Κελσίου. Μέγιστη εγκατεστημένη... θερμική ισχύ 9,6 ΜΒ. Οι τελικές χρήσεις είναι η τηλεθέρμανση των περισσότερων κτηρίων δημόσιου χαρακτήρα, των οποίων οι ανάγκες θέρμανσης καλύπτονται από το Δήμο Αλεξανδρούπολης, το 20% του διαθέσιμου θερμικού φορτίου και η θέρμανση κατέτηση αγροτικών εφαρμογών με έμφαση στα θερμοκήπια από 50 έως 60 στρέμματα και καλύπτει το 80% του διαθέσιμου θερμικού φορτίου. Η διακίνηση των γεωθερμικών ρευστών και η ανακυκλοφορία νερού έως τις τελικές χρήσεις θα γίνεται μέσω εκτεταμένου υπόγειου δικτύου προμονωμένων σωληνών συνολικού μήκους 16 χιλιόμετρων.
Next slide.
Εδώ βλέπουμε τις κύριες διατάξεις του έργου. Αριστερά βλέπουμε τις διατάξεις άντλησης του θερμού νερού, δηλαδή οι γεωτρήσεις. Στη μέση ο θερμικός σταθμός, το σύστημα εναλλαγής θερμότητας. Αμέσως πιο κάτω το δευτερεύον δίκτυο ανακυκλοφορίας και αριστερά είναι οι γεωτρήσεις επανεισαγωγής. Ο θερμικός σταθμός αποτελεί το κεντρικό λειτουργικό σύστημα το οποίο εξασφαλίζει τη θερμική εναλλαγή και τις διεργασίες διανομής της θερμικής ενέργειας και των ελέγχων συγχρονισμού και θερμικών φορτίων. Η εξέλιξη, εδώ τώρα βλέπουμε την εξέλιξη της πρώτης φάσης εγκατάστασης. Πάνω αριστερά είναι η γεώτρηση Α3, η εξόρυξή της, που μας δίνει 110 κυβικά και 89 βαθμούς Κελσίου. Κάτω είναι η εσωτερική όψη του θερμικού σταθμού. Πάνω δεξιά είναι η γεώτρηση Α6, η οποία μας έδωσε τους 99 βαθμούς Κελσίου και 40 κυβικά την ώρα, και βλέπουμε εκεί τον ερευνητή του ΕΛΓΟ Δήμητρα, συνεργάτη του Δήμου μας, τον κύριο Δαλαμπάκη, και κάτω δεξιά είναι τα δευτερεύοντα προμονωμένα δίκτυα ανακυκλοφορίας. Next, please. Κύρια δημόσια κτίρια του δικτύου τηλεθέρμανσης είναι τα κτίρια του Δήμου Αλεξανδρούπολης στην Τραϊανούπολη και περιλαμβάνουν τα σχολεία, το Δημοτικό και Γυμνάσιο της Εκκλησίας Άνθειας και Αριστίνου, το παιδικό χωριό ΣΟΣ με 8 κτίρια, καθώς και τον Σύλλογο Εθελοντών Αιμοδοτών Τραϊανούπολης και τον Πολιτιστικό Σύλλογο Ανθίας ο Σπάρτακος. Η δεύτερη φάση έργων τηλεθέρμανσης αφορά την επέκταση του δικτύου. Φυσικά θέλω να πω ότι το έργο ξεκίνησε τον Ιούλιο του 2020 και θα ολοκληρωθεί και θα παραδοθεί προς χρήση τον Αύγουστο του 2022, αν δεν ζητήσει ο κατασκευαστής και άλλη παράταση. Εμείς όμως προετοιμάσαμε και τη δεύτερη φάση για τη διανομή θερμότητας σε οικισμούς της Τραϊανούπολης, του Δήμου Αλεξανδρούπολης, και αυτά είναι το Δωρικό, Αετοχώρη, Άνθια, Αρίστινο, Λουτρά και Αγνάντια. Συμπερασματικά, next, please. Η καλή ποιότητα και η υψηλή αρχική θερμοκρασία των γεωθερμικών ρευστών αποτελούν σημαντικό πλεονέκτημα για μελλοντικές εφαρμογές αστικής τηλεθέρμανσης, συμπεριλαμβάνοντας όλα τα χωριά που βρίσκονται είτε εντός του γεωθερμικού πεδίου, είτε πλησίων αυτού, συνολικά 6 χωριά. Πέραν της πρωτοφανούς κοινωνικής ευαισθησίας και δημόσιας προσφοράς του Δήμου Αλεξανδρούπολης, η επιτυχημένη έκβαση τέτοιων μελλοντικών εγχειρημάτων πρέπει να βασίζεται στη βιωσιμότητα και την ανταποδοτικότητα. Σε αυτή την κατεύθυνση και στο πλαίσιο της προμελέτης σκοπιμότητας, ορισμένοι βασικοί δείκτες είναι σε θετική κατεύθυνση. Ο ένας είναι η θερμική ενέργεια μπορεί να πωλείται σε χαμηλή τιμή έως και 0,04 του ευρώ η κιλοβατόρα, η οποία είναι 20 έως 30 φορές μικρότερη από την έως σήμερα φθηνότερη τοπική ενεργειακή πηγή, που είναι φυσικά το ξύλο. Για μία περίοδο απόσβησης 15 ετών, η καθαρή παρούσα αξία και ο αντίστοιχος βαθμός εσωτερικής απόδοσης είναι θετική. Όλα τα παραπάνω φυσικά θα πρέπει να επαναξιολογηθούν επισταμμένα στο πλαίσιο μιας καλά τεκμηριωμένης μελέτης σκοπιμότητας. Σημεία αναφοράς για το γεωθερμικό πεδίο. το γεωθερμικό πεδίο Άνθειας Αριστίνου χαρακτηρίζεται από εκτεταμένη θερμική ανομαλία. Ο ανώτερος παραγωγικός ταμιευτήρας με θερμοκρασίες από 50 βαθμούς Κελσίου έως 99 βαθμούς υπερβαίνει τα 1.200 εκτάρια. Η αναμενόμενη συνολική αξιοποιήσιμη παροχή ρευστών με θερμοκρασία έως 99 βαθμούς Κελσίου πιθανά υπερβαίνει τα 500 μέτρα, προσφέροντας θερμική ισχύ της τάξης το 40 με 50 ΜΒ σε διαδοχικά ενεργειακά στάδια. Εδώ μιλάμε για ηλεκτροπαραγωγή από 90 έως 99, για θέρμανση χώρων από 70 έως 90 βαθμούς και για τελικές αγροτικές χρήσεις από 30 έως 70 βαθμούς. Η μεγαλύτερη πρόκληση για το μέλλον του γεωθερμικού πεδίου είναι η έρευνα και αξιοποίηση του βαθύτερου υδροθερμικού συστήματος με αναμενόμενες θερμοκρασίες μεγαλύτερες από 140 βαθμούς Κελσίου και ηλεκτροπαραγωγή. Σύμφωνα λοιπόν με όλα τα παραπάνω, το γεωθερμικό πεδίο Αρίστινου Αλεξανδρούπολης μπορεί να χαρακτηριστεί ως το πιο σημαντικό πεδίο χαμηλής ενθαλπίας στην Ελλάδα. Σας ευχαριστώ πολύ για την προσοχή σας.
Thank you, Ms. Intzepelidou. I think what you said corresponded perfectly with the slides, so I don't have to add anything more. Σας ευχαριστούμε πολύ και θα σας έχουμε στο τέλος για ορισμένες ερωτήσεις, φαντάζομαι από εμάς ή από το κοινό.
Βεβαίως, στη διάθεσή σας.
Okay, so now from the north of Alexandroupolis, we can go to the numerous Greek islands, which have their own challenges when it comes to decarbonization for various reasons. And I would like to invite Mr. Komninos. He's the director of DAFNI and the Network of Sustainable Greek Islands to share his experiences. I think, as a matter of fact, we actually collaborate with CERTH in some of those. So, Mr. Komninos, the floor is yours.
Hello everyone. Thank you, Mr. Karampinis, for the introduction, and thank you to Mr. Damatis and HellaBiom for the invitation to join this very interesting event. So yeah, indeed, I will try to give you some thoughts and some use cases, let's say, from the Greek islands when it comes to renewable heating and cooling. So if I may share my presentation, and you can confirm that you can actually
we can see it.
See it in
just put in the presentation
full screen. Okay, is it in presentation?
Fine. Yes.
Okay, that's good. So yeah, I'm Komninos. I'm the general director of the DAFNI network. This is a public interest non-profit organization of the island local and regional authorities in Greece. We're counting 56 members in total, of which 52 are municipalities and 4 are regional authorities. And we've been established since 2005. And we've been promoting sustainable development in the Greek islands with the delivery of integrated actions in the fields of all kinds of infrastructures when it comes to clean energy production, energy efficiency, water, waste, and transport mobility. Well, through a vision to enable, let's say, the transition of the islands to a circular and sector-coupled local economy, boosted by the most significant economic activity in the islands, which is tourism. So why we are actually focusing so much on islands? And well, insularity in the islands has several challenges. And most of you are aware of that, but they are heavily affecting the operation of infrastructure, so population seasonality, due to the dependence of the local economy and tourism, which results to high operation costs for local infrastructure. Well, limited human resources in many cases to operate infrastructure, high dependency on fossil fuel when it comes to energy production and transportation. We have sensitive and unique ecosystems, which poses great challenges when it comes to the siting of infrastructure. So there's a limited available space and conflict of uses of land. So the above challenges, which we consider the most critical ones, requires tailor-made solutions for the islands. When it comes to energy production, and yeah, this is quite relevant, especially when it comes to decarbonizing the heating and cooling sector. We should bear in mind that the energy production, the electricity production cost in the island, it is way higher than this in the mainland system. And here we have data from 2017 now that fuel prices and diesel prices, they are rising, have risen significantly. These prices are also greater, and you can see the difference between the average electricity cost in the mainland system, which is the red line, and the blue lines where the different islands, they are not actually interconnected with the mainland system. So we see here that there's a significant, let's say, margin of cost, which can actually boost the decarbonization of the energy systems in the islands. Besides that, we have also very sensitive systems, and we need to balance the loads and the production in order to maintain stability in terms of frequency and voltage and ensure the safety of the electrical systems on the islands. And of course, seasonality. When it comes to the energy demand, we can see that the energy during summer times, it's multiple times higher than that on the rest of the year. When it comes to other challenges, you are all familiar with the vulnerability of islands to climate change, the lack of water, the limited resources, the lack of economies of scale, the higher cost due to transportation, and the fact that the islands, in many cases, they are like small countries, actually. What I used to say is that Paros Island, an average-sized island in Greece, is the same size as Malta, which is a member state, of course, not of the same population. However, it still needs to maintain the same amount and the same number of infrastructure on the island and operate them efficiently for the permanent population and the visitors. So when it comes to clean energy transition and local energy planning in the islands, there's been a pipeline, let's say, or a sequence of activities shedding light on these increasing characteristics of the islands and their great challenges when it comes to energy transition, clean energy transition, and decarbonization. I will not go through them very in detail. DAFNI has been, let's say, in most of them involved and a founding member in many of these activities. But recently we have also an islands facility, the European Islands Facility, that actually supports the implementation of studies to decarbonize the island energy systems. And here comes also the significant role of CERTH, that is a part that is actually representing more or less Greece in the consortium managing this facility. And we have a very, let's say, efficient collaboration in the projects that we have actually facilitated and we are running with our municipalities. Here you can see a set of these projects. I would like to focus mainly on number 6, 7, and 8, and gradually I will also start presenting some more details on actual projects on heating and decarbonizing heating. But here you can see projects that they are focusing on the potential exploitation of local biomass in the islands. Proposal number 6, project number 6, is focusing the island of Ios, where there's significant production of agricultural biomass through the local cheese production unit. And we are working closely with the municipality. It's a municipal production unit, and we are working closely with them to mature a study for a small-scale anaerobic digestion unit, which can actually exploit, besides of producing electricity, can also produce, it is foreseen to produce also heat to cover the heat demand of the cheese factory. A similar project is also foreseen for Limnos. 2 projects that have been launched the last couple of months, and we are expecting to have the results in the next year. So these are 2 examples of the efforts to exploit a local produced biomass from agricultural activities in 2 islands that they have a significant agricultural sector besides of the tourist activities. Project number 8, you can see the Gecko project. This is a green hydrogen ecosystem on Kos Island, and here we are also foreseeing the exploitation of fuel cells to cover also heating demand in the electrified heating demand in municipal buildings. Through that, which are projects that we are currently studying, and we're trying to boost, let's say, the exploitation of renewable heating and cooling in the islands, I would like also to present one of the, I would say that is the first actual geothermal district heating project in Greece that was established several years ago in the settlement of Polyknitos in Lesbos Island. Similarly with the Alexandroupolis project, but in a rather smaller, let's say, scale. Here we had a municipal drill that was actually awarded to the municipality of Polygnitos at that time, back in 1985 actually, to be used to cover heat demand of the greenhouses in the area. There was actually a quite unsuccessful effort to exploit this geothermal field in the first years. And then approximately in the 2000, there was a EU-funded project and a consortium among the University of Aegean and other parties that actually established a district heating network that delivered heat through a geothermal field and a heat exchanger to 6 municipal buildings and also greenhouses. Unfortunately, the specific project and the pumping station of the geothermal fluid failed after a few months. And due to different reasons, the replacement of the specific pumping station and the renovation of the system never actually took place. So again, through NSOE, we have submitted the proposal here, and there is a significant effort by the municipality submitting a business plan in the prefecture a few months ago to renovate the system and put it back in operation and cover additional energy demand through this first, let's say, pilot district heating, geothermal district heating network in the Lesbos island. Another project I would like to focus is the Circular Greece project. This is a live integrated project. It's an 8 years project implementing the Circular Economy National Strategy, conducted a couple of years ago and submitted to the European Commission. And here what we have actually highlighted is the need for integrated, let's say, agro-food waste valorization at island scale. Islands, you know, we consider them as closed systems that generally the influx and the exploitation of resources bear significant costs. So the effort here is how we can actually maintain of exploiting agro-food and bio-waste at the island scale. Here we are again trying to target exploitation of locally produced bio-waste, and here you can see in the previous slide, apologies, we have 5 islands participating as pilot, and the use cases here, it is Santorini, Thira at the south, Tinos, Paros and Antiparos and Alonissos, and we're actually trying to focus on bio-waste exploitation mainly in Tinos and Paros, where they have the most significant loads, and secondarily in Thira. And again, the effort is to investigate the possibility of micro or small scale anaerobic digestion, or even the local production of solid fuels to be used for heat production on the islands. And through that, I would like to present a few slides for Kythnos Smart Island, where I'm actually now located in Kythnos these days. And here we have a large-scale innovative project, which we're actually implementing together with National Technical University of Athens. Here we have a set of several interventions in the electrical system, the transport and mobility, street lighting, waste management, water management, and building and public space retrofitting. And I will try to present a coupling here of waste management and buildings retrofitting, but also a coupling between buildings retrofitting and smart grids. So here you can see an area which was used, well, in a not typical way for the deployment of bulky waste. And we have been trying to set up a settlement of integrated management of this municipal bulky waste and aim to their valorization. Here you can see different photographs of our efforts, let's say, to separate the waste that was thrown there, several big, let's say, bulky waste items of all kinds, like electrical appliances, mattresses. So we managed to send out of the island approximately 300 mattresses the last months, and 2 containers of electrical appliances and other waste. But what we have been actually trying to focus now, and we think that this can be a quite significant action with high replication potential in other islands, is actually the local exploitation of the bulky wood waste for heat production, and not heat production. So What we're trying to do is to produce local production of pellet, actually to break down the wood. And you can see here different types of wood that they are thrown in this area, and a large amount of them comes out of renovations because of the touristic development of the island. And usually this wood, it is from painted wood or impregnated, let's say, wood waste that it cannot actually be recycled. We've been looking, let's say, possibilities to use this wood for producing, let's say, artificial wood surfaces. But it has been very difficult to manage to establish a contract with a company that could actually receive this wood, because it is not standardized. So you can have different types of wood with different paints, and this has been not easy to agree with anyone to receive this kind of wood. So what we are planning to do is produce locally, well, pellet or to wood chips, let's say, from this mixed kind of wood, and procure a solid fuel-fired boiler and produce heat for a school building. Of course, what we've been looking very intensively is a set of different filters that will be used to capture the different emissions of the wood after being burned. But we think that in this way we can maximize, let's say, the potential of local circular management of this type of bulky wood waste, and maximize also their valorization for the local replacement of imported diesel for the production of heat in one of the schools. Last but not least, and well, the previous one was, it was an effort to also combine waste management with building retrofitting and replacing an oil-fired boiler. And besides that, we have been already establishing a hybrid, let's say, system to upgrade another school, the high school, and maximizing the decarbonization of the heating system. Here you can see the old oil furnace, oil-fired boiler that was in a very, very bad situation. And well, one quite typical solution of combining a high temperature heating pump with an oil-fired condensation boiler system of high efficiency. Actually, the primary system will be the heating pump, and the secondary backup heating system will be the boiler, which we expect to operate very limited time of the year. And we use, as you can see, a significant buffer tank to collect and distribute the hot water distribute to the existing, let's say, distribution system of the school. Of course, we have established, installed the BMS in order to control the heating load and the working hours, but also monitor the operation of the system. And we are considering, and this is one of the significant issues here, of how you can actually use electrical appliances like heat pumps as flexible loads to enhance the electrical system's efficiency. And this will be established through smart meters that will be installed on the building and will allow the bilateral, let's say, communication between the buildings and the local operator of the grid. There are also future interventions in the specific building, which are quite typical to increase the energy efficiency of the building. And with that, I would conclude presenting you different diverse solutions that they're all targeting towards the maximizing the decarbonization of the clean energy transition of the islands. Thank you.
Thank you very much, Mr. Komninos. First, I have to say you're very lucky that you can deliver your presentation from Kythnos. And I also find it very important that you're also focusing not just on the biomass exploitation, but also on the air emission control devices that are needed in such a system, especially in a sensitive environment like a school. But we can discuss these and other issues at the end of this session. So thank you again. I would like then to introduce Mr. Kostas Kyriakopoulos from the DETEPA, the Municipal District Heating Company of Amynteo, moving now again in the cold north of Greece and in a region that is significantly challenged by something that has to be done at some point, but still poses tremendous social pressure on the area. And I'm talking about, of course, what we call the lignification or the coal phase out of Greece. So, Kostas, the floor is yours.
Good afternoon to everyone, and thank you very much for the invitation. My presentation will explain the reasons how we transited from a lignite model of district heating to a renewable energy district heating system. Our region, Western Macedonia region, has five power stations owned by the Public Power Corporation, the PPC, that are installed to system the basis of the electricity production and energy sufficiency of the whole country. That's the reason why our region is called a coal region. Can we move to the first? So in our region, the coal region, there are 3 district heating networks currently in operation, which utilized the heat waste from the lignite combustion in PPC systems for the last 20 years. These power stations in the last years served the heating needs in Kozani, Ptolemaida, and Amynteo. The district heating networks in our regions have been developed as municipal enterprises. So heat was procured by PPC, by Public Power Corporation, based on a contract, and then it was distributed.
Kostas, we have lost you for a while. The sound is off. You cannot hear you now. Nikos, is it just me or we all have the same problem?
Yes, we can hear. No.
Kostas, can you try again to speak, or you don't seem unmuted, so something must have happened on your side, I think.
Now?
Yes, now yes.
Oh, okay. So, let's continue. I was telling that Municipal District Heating Company of Amynteo is a municipal enterprise and is owned by the Municipality of Amynteo. The company has constructed all the necessary district heating infrastructure and operates the district heating system and commissions the district heating to the final consumers. The system has been installed in the wider region of Amynteo due to co-financing. The next page. So, as I mentioned before, the district heating networks in Western Macedonia were highly related and dependent on the operation of the PPC lignite power stations. Our district heating system, Amynteo district heating system, until 2020 was served by Amynteo electric power station. Amynteo electric power station had a capacity of 600 megawatts and was, of course, a coal-fired power plant. The district heating system until 2020 was connected to the 2 units of the steam electric power station. And of course, this heating system had all the necessary auxiliary systems. It is an extensive network connecting about 2,000 public and residential buildings. It was first constructed during the
We've lost you again, Kostas. Still out. Can you say something now?
Is it better now?
Yeah. Now. Please continue.
It is better now. I selected another microphone.
Yeah.
It's better.
Yeah.
Okay, so the district heating system consists of all the necessary systems, district heating distribution networks, the pump stations, the heat exchangers in every consumer's house. Next page. Okay, some data about the system. First of all, the current tariff is 56 euros per megawatt hour, including VAT. So if we take into consideration that the current heat and gas price is over €1 per liter, we can see that the cost of the district heating megawatt hour is less than 50% of the equivalent oil cost. The total demand of heating in our consumers is about 45,000 megawatt hours, and we must produce a total amount of 60,000 megawatt hours in order to serve all the heating demands. Now, due to the developments in the European environmental legislation in the last years, lignite generation, as you know, has been dropping, and until the end of 2028, according to the new National Energy and Climate Plan, will stop. Since year 2013, all electric power units in Greece were obligated to pay for each ton of CO2 that they emit. Except of that, the changes in the European emissions trading system that were decided as part of the European 2030 framework for climate and energy have led to a peak price in the CO2 emissions, amounting from about €7.5 per ton in year 20.
Lost you one more time, Kostas. Have you changed something on your side now? Does it work? Kostas, can you hear me? You're still muted. Or we cannot hear you. Nope. Nothing still. Nikos is suggesting that you restart your computer, but obviously we'll lose you for a while. Still nothing. Okay, I don't see if I think Kostas probably disconnected. So maybe we can continue until he connects again with Vasilis, if he's here. Vasilis? Okay, thank you for stepping in and saving the flow of the program. So just a short introduction. Vasilis is a very good collaborator of us at CERTH in the BCOOP project, director of the energy community of Karditsa, active in, let's say, in the biomass and bioenergy sector as well, what you couldn't hear, the part that you couldn't hear from Kostas. So without, let's say, further delay, Vasilis, the floor is yours, and we can see later on whether we can continue with Kostas, who I see has connected.
Okay, so Manolis, thank you very much for your introduction, and I would like to thank you for the invitation to participate in this great webinar, HellaBiom and CERTH. I would like to congratulate on the previous presenters for the great presentations, and I think that this is a great way to connect to each other and learn about other initiatives about heating and cooling sector. So my name is Vasilis Philippou, and I represent energy community of Karditsa. I have prepared a few slides just to give you the idea of energy community and not get into the details, but I'm right here in order to answer to you in any question you may have later. So let's start. Okay. ESSEC energy community operates in Thessaly. As you all Greeks know, it is an area with a strong agricultural production, but the continuous expansion of the local fossil fuel network threatens the uptake of the renewable energy solutions. But at the same time, the region has great biomass supply chain potential through agricultural, forestry, and wood processing industries that can easily support the uptake of bioenergy technologies. Next slide, please. ESSEC founded in 2010 in order to foster the renewable energy in the region. In 2019, the energy cooperative was converted into the energy community. Nowadays, we have more than 400 members, including citizens, small, medium enterprises, and of course, municipalities. All 6 municipalities of the prefecture of Karditsa are a member of the energy community, and together we're planning in order to exploit all the local resources. So in 2017, the energy community found a solid biofuel plant in order to take residual biomass, processing, and convert into solid biofuels. You can see the picture, some of the biofuels that we have produced. You can see the biomass plant and some of the machinery that we have and in order to process the local biomass. But one of the biggest achievements that ESEC is trying to do is that ESEC is trying to create local ecosystems of key stakeholders such as municipalities, academic institutions, and other collaborative initiatives in order to exploit all the local resources and to produce energy for heating, cooling demands, or even electricity. Next slide, please. The main goal of ESEC was to produce electricity from biomass. You can see in the middle that this is the supply chain as a sketch, as ESEC has sketched it before the creation of the biomass plant. And the main idea was to collect all the residual biomass coming from agrobiomass, municipalities, forest cooperatives, forest residuals, and other industries, wood processing industries, take this residual, produce something, maybe it's a biofuel, maybe it's direct heating or electricity, and give it back to the local community. As I said, the main goal was to produce electricity from biomass, but we couldn't achieve it because the budget was too high and the supply chain was not exist. So the first step was to found a biomass plant in order to create the biomass, the supply chain. So since 2017, we're trying to create our supply chains, and as you can see in the pictures, we managed to operate a reliable supply chains. We collect the residual from energy crops, from forest residuals, in cooperation with the Manchenis municipalities, agricultural residues in small amounts, of course, from wood processing industries. The things are very mature there, so we can collect all the wood that coming from industries. And our collaboration with local municipalities allow us to expand our supply chain and include the city tree cuts, the prunings. Next slide, please. So this is in general what SEC is doing. What we're trying to do here is to make an ecosystem of local key stakeholders in order to exploit all the local biomass and produce energy. Since November 2020, we participate as a pilot case in the BICU project. As Manolis said at the beginning, we have a very good collaboration with CERTH in this matter, and we are a pilot case. Next slide. As you can see here, there are 4 pilot cases in this BICU project. In Spain, Goyener, in Italy, Fiber, in Poland, Municipality, and of course, ESEC in Greece. Our goal is to found a BICU community in order to exploit the local resources and to produce energy. Yeah, okay. So our goal in this project is is to exploit some feedstocks that we had in mind, but the things now are more mature with the collaboration with the local municipalities. We're trying to achieve it. The first one is to exploit the local city tree cuts, the city prunings. The municipality of Karditsa perform each year the city tree cuts, and there are huge amounts of biomass. This biomass right now ends up to illegal landfills and many times burn in order to produce carbon dioxide in the atmosphere. In order to exploit these residues, we join our forces with the municipality, and together we're trying to process this biomass and convert it into a solid biofuel such as wood chips or pellet in order to produce thermal, to cover the thermal needs. Another municipality that we have a great collaboration is municipality of Plastiras Lake. It's a mountainous municipality. We're talking about the residual biomass, the residual forest biomass that remain in the forest and many times produce many problems such as fires and other hazards. So our goal here is to create a pilot project in order to first record all the residual biomass that is in the forest and then collect and exploit this biomass for heating purposes. And the third feedstock is it's a bit different from the other two. We're talking about the coffee. We're talking about the residual coffee that remains in the coffee houses after they produce our coffee to drink. So we have a residual there. We have some amounts, and in order not to end up to landfills and create problems, we're trying to create a network of collection of the residual coffee, and then mix this residue with wood and produce solid biofuel. So we have three feedstocks in order to produce solid biofuels. Next slide, please. Our final goal is when we can take this feedstock to produce mixed pellet or individual pellet from its feedstock and sell it to end users, or ESEC play the role of an ESCO, install and operate a biomass boiler in order to sell direct heat to end user. Our main focus is on biomass, and in order to fix and create a reliable supply chain, because this is very tricky in order to produce energy from the biomass. We try to involve all stakeholders in order to provide some social, economical, and ecological benefits in the region. So these are for my part. Just to give you first idea about what the energy community is doing here in Karditsa. I remain from your questions.
Many thanks, Vasilis, for this excellent presentation. And I think we can try again with Kostas and see whether we can resume. Kostas, can you hear us, and can you more slowly speak? Nope, still nothing, apparently. What we can do is that I can call you on the phone, and maybe I can put it next to or me or Nikos can call you on the phone and try to do it on the microphone. Is that okay with you?
Okay.
Now we can hear you. Okay.
Oh, okay.
Everybody needs a little threat.
Nice. So we were, I think, okay at this page. I hope that the voice will not stop again. So I was telling that based on the European environmental legislation, the cost of emissions, the changes on the directives on industrial emissions, all these reasons led to Amynteo power station to finally close in 2020. And so we had to find a different way to serve the thermal needs of the district heating system. It was necessary for us to examine solutions that will not be based on the combined heat production using lignite as fuel. It was urgent to find an economic viable solution to meet the district heating needs with renewable energy sources. And all of this would have to comply with the provisions of the Directive 27 of year 2012 about energy efficiency, because the district heating system should be an efficient district heating system using at least 50% of RES, of renewable energy, that would be biomass. So, taking into account the local renewable energy sources capacity, we examined two different technologies. The first one was only heat production by biomass boilers, and the second one was combined production of heat and power, CHP, using organic cycle. And we made a comparative analysis of these two. The scenario with the optimum financial performance was the one with only heat production from biomass boilers, because this solution included the lowest annual fuel needs and the lowest initial investment cost. The financial performance, the IRR of the organic cycle was better, but the initial investment cost, the capex, was forbidden. So, next page. So, as I mentioned before, we concluded to a biomass thermal power plant. The capacity of the system is 30 megawatts, and it includes two boilers of 15 megawatt each. The technology is movable client grade. The system efficiency is theoretically 88%, but this is achieved only with good quality wood chips. The real boiler efficiency is about, I can tell, 80%. We use a mixture of biomass and lignite with a ratio of 60% biomass and 40% lignite. Biomass is a mixture of wood chips and corn stovers. Lignite is used in the first years for reasons of secure fuel sufficiency. Some characteristics of the boilers. The boilers have 4 zones. Each zone has individual primary air feed. The fuel consumption is about 8 tons per hour. The lower calorific value of the fuel must be at least 2 megawatt hours per ton. The maximum pressure of the boiler is 19 bars. The operating pressure is 14 bars. The water temperature at the inlet of the boiler is 70 degrees, and the outlet water temperature is about 130 degrees. Next page. Okay, I have already mentioned these things. The project cost was about 12 million euros, 1,000 watt, and was financed by half by the European Cohesion Policy Funds through the National Strategic Reference Framework, ESPA, 2014-2020, and the rest of the cost was covered by loan by the district heating company. The commissioning of the system was on October of 2020, so this is the second period that we operate the two boilers. Next page. Okay, now there are some pictures of the project, of the system. The first one is a top view of the whole system. We can see the warehouse of the biomass on the left. The feeding system, here is the back view of the feeding system. The feeding system consists of 3 sections with a moving floor, so we can mix 3 different fuels with this system. Then the fuel is led to a vibrating conveyor that leads the fuel into tanks in the boilers. The fuel, as I said, is a mixture of biomass and corns. Next page. Okay, here are some pictures from the design of the system. The boiler is self-contained with 4 circulation. It has a movable inclined grate. It is a reciprocating grate. Of course, it has horizontal and vertical ducts. The heating surface of the boiler, except from the furnace panels, it also includes main surfaces of water heaters, the economizer. It has 6 economizers. The water inlet of about, as I said before, 70 degrees starts from Eco 6, and then it travels through the panels, through the other economizers, and the output of the boiler is about 130 degrees. Down we can see a side view of the system, the tank, the feeding system, the inclined grate, and the grate there is the wet ash conveyor that drops the ash outside of the system. Next page. Okay, here is a side view of the whole system. The moving floors of the feeding system, the conveyor, and also it's a top view of the whole system. We can see every detail here, I think. The 2 boilers, the chimney, it included everything. Next page. Okay, and finally, here we can see all the possible fuels that we use to the boilers. These values are actual values, and the prices are real prices that we purchase these fuels. The lignite we use has a calorific value of 2.5 megawatt hours per ton, and we buy each ton of lignite at about 34 euros per ton. So we can say that we buy energy from lignite at about 13.5 euros per megawatt hour. The agricultural residues that are corn residues, as I said before, they have average 3.5 megawatt hours per ton, and we buy 45 euros each ton. So we buy coal residues about 15 euros per megawatt hour. We also buy wood chips, an average price is about 60 euros per ton, maybe.
We lost you one final time, Kostas, but I think now we are close at the end of the presentation anyway. Yeah, no, sorry, it doesn't seem to be working, but I think the main picture is clear, and why, let's say, that the biomass fuels are competitive, really cost competitive compared to the oil alternative, and on, I would say, mostly similar level with lignite, which I think excludes also the CO2 cost of the lignite, right? Well, we cannot say that, but we cannot hear you saying that, but I think that's true. Okay. Thank you, Kostas, for that, despite the problems. So maybe now I can invite the other panelists to turn on the cameras. Nikos, I think also for you. Mr. Georgios, you can do the same if you want. And I haven't seen any questions in the Q&A. If it's not so, Nikos, correct me. But I was thinking about some, let's say, more general questions that could be addressed to our speakers. And I think we can organize them perhaps by technology, if you agree, Nikos, as well. And I would start with geothermal, which was discussed as a solution by Ms. Intzepelidou, by Mr. Komninos as well. And I'm not so technical with geothermal. So the question I would like to ask here is whether there have been any kind of social opposition to such solutions. We have heard in the past, for example, some experiences in other Greek areas related to power production with geothermal fields. So, and with renewable energy technologies, often there's a lot of misinformation and confusion about. So, I would like to check whether this is the case. Κύριε Τζεπελίδη, ρώτησαν αν συναντήσατε καθόλου αντιδράσεις στο θέμα της εκμετάλλευσης του γεωθερμικού πεδίου, όπως υπήρχε στο παρελθόν σε κάποια ελληνικά νησιά που έγιναν προσπάθειες, όχι επιτυχημένες, και έχουν δημιουργήσει, νομίζω, κάποια θέματα στον τομέα της γεωθερμίας.
Στην τοπική κοινωνία συνήθως οι αντιδράσεις σε κάτι νέο είναι αναπόφευκτες. Από ό,τι σας είπα αρχικά, οι έρευνες ξεκίνησαν από το 1980, επομένως οι όποιες αντιστάσεις και οι όποιες απορίες κάμφθηκαν με τα χρόνια. Πλέον γίνεται μεγάλη συζήτηση για την πράσινη ενέργεια και εδώ και αρκετά χρόνια έχουν καμφθεί όλες οι αντιστάσεις. Μιλάμε για ένα καθαρό προϊόν, μια ενέργεια που βγαίνει από τη γη μας και πρέπει να την εκμεταλλευτούμε. Αυτό έχουν καταλάβει οι συνδημότες μας εδώ. Πρέπει να την εκμεταλλευτούμε προς όφελος της τοπικής κοινωνίας και αυτό κάνουμε. Και γι' αυτό συνεχίζουμε και με την επέκταση ώστε να θερμάνουμε και τους οικισμούς γύρω από το γεωθερμικό πεδίο. Και φυσικά το μεγάλο στοίχημα είναι για το αν το πεδίο μας έχει και υψηλότερους βαθμούς, γιατί αυτές είναι οι ενδείξεις για να περάσει από χαμηλής ενθαλπίας σε μέσης ενθαλπίας, για να μπορέσουμε να κάνουμε και ηλεκτροπαραγωγή για να υπάρχουν έσοδα και στο Δήμο. Αν αυτό είναι εφικτό. Είναι υπό συζήτηση ακόμη και περιμένουμε τους ειδικούς να μας απαντήσουν.
Ευχαριστούμε πολύ. Thank you very much. So basically the main message for the, I say, non-Greek speaking audience is that since the geothermal field in Alexandroupolis has been under investigation for a long time, social opposition has been more or less addressed by now, and now it's clear that this is a clean and sustainable energy resource. I don't know if Mr. Komninos has any comments on the geothermal experience, considering that some of the, I think, controversial projects in the past were in island communities.
Yes, Manolis, thank you for the question. Well, I had to move from I was at the town hall, and I'm actually now at the one of the primary school where we intend to install the boiler. But yeah, I mean, there has been an opposition, but mainly, you know, with high enthalpy fields, and that was the case in Milos Island, and next was followed by Nissos Island, and that was the case for electricity production and not for district heating and networks. And well, this is mainly based on an accident with one of the geothermal drills in Milos. Currently, the truth is that in the specific islands, Milos and Nissos, the opposition remains, and geothermal energy is combined with a resource with potential environmental impacts, and this has to be tackled, and more work needs to be carried out there for raising awareness to the locals. But when it comes to other islands, we have cases like in Lesbos Island, where there's an interest, let's say, from the local municipality, the municipality of Western Lesbos, that they host also the project in Poliditos. And there's a geothermal field in Stipsi that there's a license by PPC Renewables of 8 megawatt electrical production, and there is an intention from PPCR to continue, let's say, with their last investigation drills and proceed with the licensing and operation of the system there. But we see that there is a significant interest also with the low enthalpy fields. We're actually now conducting also a study with the municipality of Ikaria, where there's a geothermal field with potential economical, let's say, feasible exploitation there, both for electricity and heat production. And we have also other cases with low enthalpy geothermal fields that the local municipalities, they are interested, let's say, to proceed with implementation. So I think that there is room, let's say, to work there, and also try to overcome, let's say, the barriers and the concerns, let's say, of the locals with the past experience that you mentioned.
Thank you very much. Obviously, and goes without saying, if anybody wants to intervene on something about what we are saying, you're free to, let's say, to interject in the discussion. But I will move on then to solar heat. It was, I think, the technology that was singled out by Professor Maniatis in his introductory keynote speech, and Mr. Georgis gave a very interesting example in the school in Messini. Mr. Georgis, how are you seeing this possibility being replicated in other, let's say, municipalities? Was it like a more unique example that could work in Messini because of special conditions, or is there still a very untapped potential that we can, let's say, work on?
No, we consider that this study is something like a prototype. We hope to make again that.
More projects for that.
Yes, more projects. We hope, yes.
Perfect. Okay, thank you. And maybe I think because also time is running out, I think this is also very, at least for me, a very interesting issue. Biomass and bioenergy in the framework of renewable heating and cooling in communities. The last two speeches were focusing on that particular aspect. Also, Mr. Komninos gave an example where it's connected with waste management, I would say. But I think it has been under investigations by other, let's say, of our panelists. If I remember correctly, Mr. Georgis, you were looking into a project about prunings in Kalamata, if I'm not mistaken. I don't know if he has proceeded or not. And in the past, I think we were also hearing something about Alexandroupolis, about, I think, biomass in combination with geothermal. So I don't know with whom should we start. Maybe Mr. Georgis, you would like to say something about that, or is it still in progress? You're muted.
It is still in progress. We're looking for funding.
Okay. Well, okay, that's good to know, and perhaps a good opportunity for collaboration.
Oh, yeah, of course.
Κυρία Intzepelidou, στο παρελθόν είχαμε ακούσει από Αλεξανδρούπολη κάποιες πρωτοβουλίες για συνεκμετάλλευση, να το πω έτσι, της γεωθερμίας μαζί με βιομάζα και βιοενέργεια. Το έργο που παρουσιάσατε τώρα είναι καθαρά στοχευμένο στο γεωθερμικό κομμάτι. Οπότε είναι το κομμάτι της αξιοποίησης βιομάζας ακόμα στα ενδιαφέροντα του Δήμου, έχει ατονίσει. Πώς μπορείτε να πείτε δύο λόγια γι' αυτό?
Προς το παρόν, σήμερα μίλησα για το γεωθερμικό πεδίο, την αξιοποίησή του με αστική τηλεθέρμανση. Όλα είναι υποσυζήτηση, εξετάζουμε όλες τα ενδεχόμενα για αξιοποίηση 100% του γεωθερμικού μας πεδίου, με ό,τι συνεπάγεται αυτό.
Ευχαριστούμε πολύ. Mr. Komninos, then, as I said, you gave this very interesting example, but I think, and it's well known that, let's say, several of the Aegean islands, especially in the Cyclades, are not really known for their biomass potential, solid biomass potential. But if you go a little to the north or to the east, in Lesbos, Chios, Rhodos, and also in the Ionian Islands, there you see forests, you see olive groves, and so on. Is this something that has been discussed or considered as a possibility?
Yes, actually, we've been investigating that for several years. Actually, back in my memories, let's say my thesis back in the university in 2005, I was actually studying there the poly-energy system in Lesbos Island, and actually we were looking into the possibility of exploiting the geothermal field in Stypsi and also polyhedros for heating, but also biomass exploitation combined with pump storage for storing electricity from the wind turbines, exploiting existing dam there. And so, yeah, we are always looking into the possibility of exploiting all kinds of resources in the islands. When it comes to the northern islands or the islands with more significant agro waste, well, actually, as I presented with Limnos and Ios, we are looking into bio-waste produced from activities like olive and olive oil refineries and also cheese factories. But also when it comes to solid waste, we've been actually trying to set up a project and we submitted also a couple of proposals for that, but we will keep on trying for the Sporades Islands, the North Sporades. So we have extensive municipal forests there. And we try, let's say, to establish a combined energy cooperative with the three islands, Alonisos, Skoupolos, and Skiathos, to co-exploit, let's say, the municipal forests and produce, let's say, the Sporades pellet. And that would be interesting also to, I see Vasilis smiling, and it would be interesting, let's say, to use the experience from a SEC. I know they have a significant experience, and Vasilis, they've also visited your plant in Karaditsa. But Manolis has presented also, you know, the efforts under the LIFE IP project. What we are looking into the circular economy principles is how we can actually have islands as ecosystems that they can smart, efficient, and ecological way, let's say, manage their bio-waste of all sources in an integrated way at the local scale. So this is our main effort, and regardless the size of that, we have biomass and bio-waste produced in all islands of different types and amounts, and we need to find the solutions that are adequate for that. I mean, in some cases they are going to be feasible, but when it's not, we need to find the ways, and possibly with support from the state, to maximize the valorization of the bio-waste on the islands. This is our, let's say, strategy, and that's the direction we are moving towards.
Thank you. That's very interesting. And if I can, let's say, indulge in a little self-advertisement for the project I'm working on, we think that, you know, local heat generation with what you said, agro waste. I prefer the term agro residues myself because that sounds less negative, I would say, is very meaningful because you have the local resources. You always have some kind of heat demand, and you have limited, I think, options to valorize these resources in another, let's say, way. Yeah? So it's combined quite well. So thank you for agreeing on that. Vasilis, you are, let's say, an energy community. You represent an energy community. You are active in biomass at the moment. So what are your hints and tips you can give for someone who is like Kostas, who is interested in doing something in an island community? And are you also considering as a SEC other renewable energy sources within your energy community?
Of course, I'm glad to hear that, as Konstantinos said, that they want to produce pellet from residues. It's a pleasure for us to exchange our knowledge and give whatever we can in order to achieve this goal if we ask to. Great. So. When someone wants to stay in touch with biomass is something that it's not noticeable. You can see biomass, you can see the prunings, you can see the residual. So if you're aware that you have a great amount of those residual of this biomass in your area, you can understand that you can exploit these local resources and produce energy. We can have an independent energy transition, that all European Union wants, and biomass is a great way. It's a great way to achieve this goal. So we have a lot of biomass residuals. Some places have a lot of forest. So we're talking about the forest residues that need to be exploited, need to get them out of the forest in order to better and sustainable manage management of the forest, to prevent fires. Or we have, as Karditsa have, agro residues. It's a great way to exploit them and not burn them and produce CO2 emissions in the atmosphere. ESEC do not reject other renewable energies, but as I said, ESEC focus on biomass because biomass creates a network of connections, create an ecosystem that all the stakeholders can collaborate each other and produce local, economic, social, and environmental benefits. But of course, I don't think that we have geothermal energy here in Thessaly. I'm not sure about this. I'm not aware of this, but we are talking about photovoltaic systems in order to virtual net metering with our members. It's another project that we're trying to achieve for the next years. But the first step was the creation of a plant in order to produce something and build this supply chain that we need, and all the biomass plants need to have a solid supply chain.
Thank you, Vasilis. And a question for Kostas. I don't know if you can hear us now or not. Kostas, can you hear us?
I can hear you. I don't
and
know.
Now we can hear you too. Great. So I think that until perhaps the project in Alexandroupolis is implemented fully, now the new biomass boiler at the DETEPA is probably the single largest renewable heating project in Greece. So what about the future? Do you see also potential to integrate other types of renewable energy sources, like, I don't know, geothermal? I don't know if this is relevant in the area, or solar heat. And what about replication also? Is it possible, let's say, to take the model of what is being done in Amynteo and use it in, I don't know, smaller scale boilers for small district heating networks, city, municipality level, or individual, let's say, building level?
It's depending on the local capacity of renewable sources. If one place has plenty of residues, if there are enough fuels to burn, I think it's a good opportunity to implement it to other cities or to smaller district heating networks. To be viable, I think there must be enough biomass near the boiler. For our system, I don't think that we can expand it to other renewable sources, but what we can do is maybe to convert one of the two boilers to make it CHP unit. We can produce 1 or 1.5 megawatt of electric power, the same system, and we can produce about, I think, 8 or 9 megawatts of thermal power in the same boiler. The second boiler can be as it is for only heat production. And maybe in the future we can make, we can exploit also wastes to make, as was mentioned before, better waste management towards a circular economy. I'm referring to SRF and FDF exploitation, and to make a mixture of biomass and these alternative fuels in order to completely replace lignite in the fuel mixture. This is our potential, because in our region there is also the waste management facility in Kozani, the DAFNI.
No, for sure, and it's things that is discussed
And
from time
we
to
can
time.
produce SRF RDF.
Perfect, thank you, Kostas. Nikos, I didn't see the chat. Do we have anything there, or I think we're
We
closing?
don't have, but I would like to pose a question also about biomass to Kostas and Vasilis based on their experience. We all know that biomass maybe is the most difficult renewable energy in terms of mobilizing the potential. In other renewable energy sources, once you find the potential, you just install the equipment and there you have it. But in biomass, the challenge is to mobilize it and bring it to the factories, either for heat production or for electricity generation. So according to your experience and the operation of your respective plants so far, how did you manage? How difficult did you find it? What are the steps yet to follow for that? I will start with Kostas.
Well, maybe this is the most difficult part of the whole project. Last year, on the first period of operation, it was not possible to collect or mobilize local farmers to collect agricultural residues. The previous period, we burned a big amount of agro pellets. But this year, the second year of operation, after the good results of the first year, I think that it was a significant mobilizing of the local farmers. Until now, I think we have collected about 3,000 or 4,000 tons of corn residues. I hope that in the next year, in the next years, the whole amount of our biomass will come from only local farmers, only local agricultural residues. It's not efficient to buy wood chips far from the boiler location. This is the most important thing. The biomass must come near the boiler. Otherwise, the cost is forbidden.
True. And Vasilis?
Yeah, if someone talks about biomass, the first thing that comes in mind is the supply chain. So if you don't have a reliable supply chain, you cannot produce energy from biomass. This is the hardest and the most difficult part in order to engage all the local stakeholders that you need in order to create a sustainable supply chain. you need to focus in different things in the different fractures of the biomass, I have to say. So let me explain. If we talk about the agro residues, we have a great potential, but they are scattered. There are many owners that you have to make deals with, and it is difficult to harvest and bring the biomass in an economic, reliable way in the biomass plant. So if someone can think that want to exploit the forest residues, for example, there we have a legislation, a legal legislation that it stands as a barrier because it is old, it need to change. So we try to record all the problems and then make suggestion to the ministry in order to change this legislation, and the forest cooperatives can exploit the residual biomass from the forest, because right now all the residuals remains in the forest, and this is a problem mainly for the forest because of the fires, of the floating issues that happens, and if someone wants to exploit them, he cannot. If someone, let's say, have in mind to exploit the city tree cuts, the city prunings, there we don't have a legislation problem. The owner is just one, but we need to change the awareness levels and all the and all the process that the municipality have used to perform in order to exploit and end up this biomass to the plant. So just not to, I don't want to say more, but if someone wants to exploit biomass, the first thing is a supply chain, and then need to focus in the different things in the different fractures of the biomass in order to achieve a reliable supply chain.
Thank you very much. It's indeed a very complex energy source, but being challenging, it is also a way of having more people involved. So it's an incremental step-by-step situation.
Exactly. Yeah.
We don't seem to have any other questions from the audience. We're already 7 minutes past the time. Manolis, if we don't have any other points to make, maybe we could conclude. We could say that obviously there is a very promising potential, and there's an abundance of applications in the renewable energy sources in Greece for the renewable heating and cooling sector. And I hope that all our speakers have given a very, very good examples of that. I hope that you have enjoyed our session. And I would like to thank very much all our speakers for being with us. Special thanks also to Francisco from Bioenergy Europe for having the technical support in hosting of this session. And we hope to see you. Hi, Francisco. Thank you very much once again. And we hope to see you one of our next events, either jointly organized with HellaBiom, CERTH, and Bioenergy Europe, or through other joint efforts. So thank you very much. Thank you all, and for being with us until this time.
Thank you too. Congratulations, Nikos and Manolis. Thank you. Bye-bye.
Thank
you.
you.
Thank you.
For the audience as well.
Bye-bye.
Ευχαριστούμε πολύ.